I'll start by telling you about a boy. At 11, he had published books and poetry. He writes about how he views the world and its people, and how the beauty in his everyday surroundings fills his heart. This boy's name is Tito, and he has severe autism. Like 30% of people with autism, Tito does not speak. Unfortunately, we know very little about this population. We don't know what is different about their brains because there's hardly any neuroimaging research on them. My PhD is on the brain mechanisms of auditory processing in autism. I'm interested in how kids with autism discriminate sounds and how this relates to their language outcomes. Why are some hypersensitive to sounds, while others have trouble discriminating between different kinds of sounds? What do these patterns look like in the brain? To answer these questions, I look at the brainwaves of kids with autism while they listen to non-speech and speech sounds. We tell them they sound like beeps and burps. Beeps go beep, beep, beep. Burps go ah, ah, ah. We know that infants with autism do not respond to speech the same way typical kids do. This may affect how they communicate with and perceive our social world. To look at brainwaves, I use a neuroimaging technique called MEG. MEG measures the magnetic fields on your scalp. So every time you hear a sound, your brain cells fire, and it picks up these brainwaves. Using MEG, I tested 32 kids, all of whom were verbal, until I came across a certain girl. This girl has autism, is 9 years old, and has never spoken. What I found is that compared to typically developing kids, her brain responds unusually quickly and strongly to non-speech, but to speech, her responses were sluggish and weak. Of all the kids tested, she is the only one without language and also the only one with this unusual brain pattern. This is important because I have shown using MEG that you can test for brain responses from a non-verbal child with autism. This has never been done before. It's also fascinating as it opens up new research questions. Firstly, why this difference? Secondly, would other non-verbal kids with autism, kids like Tito, show this pattern? I hope that my PhD will help uncover the neural causes of language impairment in autism, and ultimately lead to a better understanding of the minds of those with autism who do not speak. Thank you.